science. Whoop, whoop. All right, let's get into this. Sorry, my voice is a little off this morning, but it is early. All right, today's learning target for 10.6 is I will find fractional distances on the coordinate plane, right? Moving from the number line to the coordinate plane. Take a minute, convert between fractions and decimals, write all in simplest form. Boom, so it's a fraction, write it as decimal. If it's a decimal, write it as a fraction, and we will reconvene after this coffee sip. By the way, those little breath moments, or my little sip moments, are your turn to pause it if you need extra time so this video doesn't take forever. So let's do this. This would be -8 and 75 hundredths, which 25 goes into each of those, makes that 3, makes that 4. So this is -8 and 3/4. 2 divided by 5 is 0.4, so this equals 3.4. -7, or 7 halves is 3.5, so this is -3.5. That is 12 over 1,000. And how I kind of simplify this is, I know that 4 goes into this 3 times, goes into this 250 times. And there we go. 1720, it's not going to lie, I took a calculator to it. So please, get a calculator, you're going to need some. Or you can do long division, but there we go, 0.85. Well, I guess I could have done it like this, right? I could have done times 5 times 5, which 5, 50, and 35, that's 85 over 100, which 85 hundredths is 0.85, if that makes sense. So, you know, I mean, I just could have done that without using a calculator. But whatever, I'm not mad. Okay, we're going to talk about locating points on a coordinate plane. With a fractional distance. Okay, it's a lot of what you were doing. It's the same thing as the number line, but now we're going to do it on 2 different number lines, right? We're going to do it on the horizontal number line and the vertical number line here. So if I were to draw my little slope triangle here, what do we notice? So this is my x values, right? So this distance right here is going to be x1, or excuse me, x2 minus x1, right? It's the difference in these 2 x values. And then if I want my vertical distance, that's going to be my y2 minus y1, right? Okay. But what if I want to find some fractional point B right here? I want to create a point B. Well, if that happens, guys, I'm going to multiply these distances times some fractions. So notice I'm creating a wholly separate triangle right here, right? Where this distance right here, this little distance, is going to be what? It's going to be some a over b fraction times my x2 minus x1. And then this distance right here is going to be the same a over b fraction, whatever that is, times my y2 minus y1, right? Just multiply a fraction times the distance. Okay, is there anything else I'm forgetting? No. And if I really want to find it, right, I've got to take whatever that distance is and add it to the original. So the horizontal got to add it to the original x to get the x value to there, and I got to add this distance to the original y value. So it comes out, B is the point. And that point is our x1 value plus the fraction times the distance between the 2 x points. And the y coordinate is the y1 point, or y1 coordinate, plus the fraction times the distance between the 2 y coordinates. I know it looks so much more complicated than it actually is. So let's get into some practical examples where we can see this in action, okay? All right. Okay. Again, take a minute, pause it, do what you need to do. Okay. Come down here. I got a cough drop in. I got a little bit of a cough today. So notice these are each growing by 2. okay, or I guess decreasing by 2 growing 2. Same in the y direction, okay? So that means if I'm starting on the x, this is the point -7 right here, right? So we're going to go over this way, all the way over to here. And let's see, that distance is 2, 4, 6, 8, 10, 12, 13. So we know that distance is 13. And if I'm going up from here, right, all the way to B, let's come backwards. That's 2, 4, 6, 8, 10, 12, 13. So it's 13 either way, okay? And we want to find C on AB. That is 3/4 of the distance from A to B. Okay, we want 3/4 of the distance here. So if I were to split this up into quarters, 3 of the way there. Okay, so then I'm just going to have for the x, I'm going to have 3/4 times 13, which equals 39/4. And then I'm going to say, all right, we got to add this 39/4 to the original x value of -7. So I'm just going to have, all right, -7 plus 39/4. And what is -7 in fourths? Well, 4 times 7 is 28. So that's going to really equal -28/4 plus 39/4. And 39 minus 28 is 11/4. Boom, that's going to be our x value. Now for our y, we'll just do it up here because I have some room up here, why not? Our y is going to end up being same thing, right? 3/4 times 13 equals 39/4. And so let's add that for the y value of -5. So -5 plus 39/4 is really going to equal, what is that as fourths? 20? So -20/4 plus 39/4. That equals 19/4. And if I were to divide those out, guys, which I think this is easier in fractional form, 11/4 is what? 2.75, right, for the x. And for the y, 4 goes into there. 4 times is 16, and then 0.75 is 4.75. Boom. So over here, what am I looking for? I'm looking for the coordinate 2.75. So 3 is about right here. 2.75 will be about right here. Okay. And hopefully that's going to hit it about 4.75. Hey, look at that. It does. Right? Because the 5's right there, so the 0.75 is right there. And look, that's going to be our point C. Okay. Awesome. Now, this is kind of doing it separately. Another way that I like to look at it is kind of using this formula. I wanted to show you how it works separately in action. So now let's take a look at this one. All right. Find C on BA. That is this should say 2/5 of the distance from B to A. I think I fixed it on your guys' as I just found this as I was doing the work. All right, so 2/5 of the distance from B to A, okay? So again, let's go right here, and let's talk about what's this point. First of all, that's -8, and then -6, so that's the point -8, -6, that's important. And then what is this? This is going to be 2, and then 9, so this is 0.29, okay, great. So I'm going to go over until I hit that. Boom. And what is that? 2, 4, 6, 8, 10. So that's 10, right? And I'm going to go up till I hit this. A lot bigger than 10, right? 2, 4, 6, 8, 10, 12, 14, 15. So 15. Now I'm actually going to set this up using this formula up here, where I'm going to take my x1 value right here, right, which is -8. I'm going to say I need to add that to, what's the fraction? 2/5 times the distance, which is 10 in the x, and then my y is going to be the -6 plus 2/5 again times my distance of 15. And let's see if we can work that out a little simpler, okay? 5 goes in 5 once, goes into 10 twice. So what am I going to end up with? -8 plus 4. Down here, 5 goes into 5 once, goes into 15 3 times. I'm going to end up with negative 6 plus 2 times 3 is 6. So what does that become? That just becomes the point. Let me scoot it up so you can see it a little bit better. Negative 4, 0. So if I go to negative 4, boom, 0 right there, and that is the point 2/5 of the distance, point C. Look at that. So this is kind of doing it separately. This is doing it all at one time. This is my preferred method for this, but we'll let you see what you do. All right. Take a breath. Write down what you need to. Just absorb it. All right, let's go to the next. Okay, and what does this say? Locating a point. I bet you that says coordinate plane. All right, I have my notes out. On a coordinate plane with a given ratio. Now this is going to be very similar to the last lesson. There is a way to look at that ratio, but at the end of the day, guys, we want to change that ratio to a fraction. So for a ratio m to n, we're going to say step 1 is this. Find the fractional distance. Which is m over m plus n. Okay? That's going to give you the fraction, which we talked about that in the last lesson. Step 2 is multiply times the horizontal, that's x, and vertical, that's y, distance. And then step 3 is add to x1 and y1 for a new coordinate. I guess I could write it like this to make it a little bit. And to x1, y1 for a new coordinate. Okay. Again, pause this. Let's go on down here and work on this. You can see I already started it. Draw this triangle right here. I actually wrote 9, but that's wrong. It should be 2, 4, 6, 8, 10, 11. Boom. And then it's 2, 4 for the y distance right there. Okay. And let's go ahead and do step 1, which is just convert that. It says find C on A over B such that the ratio of AC to CB is 1 to 2. So that's going to be 1 over 1 plus 2, which equals 1/3. Perfect. All right. Now, let's go ahead and look at my x. What's that going to be? Well, and I kind of go back between methods, guys. It just depends on what your preference is. Let me scroll up so you can see this a little better. So I'm going to have 1/3 times the distance of 11, which equals 11/3. All right. And I'm going to add that. I'm going to have negative 5, which is my x1 value, plus 11/3, which we know is, let's see, if I want to convert that to the thirds, right? What I'm doing, guys, I can write any number over 1, and I'm just going to go times 3 times 3. So this is negative 15 plus 11/3, right? Which is going to equal what? Negative 4/3. Okay, perfect. And then I've got over here the y going to be 1/3 times 4, which equals 4/3. Okay. And then I'm going to have, all right, negative 2 plus 4/3, and negative 2 is just what? If I times 3 times 3, I'm going to end up with negative 6/3 plus 4/3, which equals negative 2/3. So my new coordinate for my C point is negative 4/3, negative 2/3. And let's see, negative 4/3 would be negative 1 1/3, negative 1, and a third, and then negative 2/3 is right here. So point C is going to be about right here. Am I estimating a little bit? Yeah, of course. It's not an exact graph. All right, why don't you guys take a minute and see if you can follow those steps. Just draw a line down here dividing everything. And solve this one. Ready, set, go. Got cold, needed to be warm. All right, so hopefully you pause it, take your time. Oh, and I guess I didn't really set this out in steps. So this was step 2, right, for both sides. And this is my step 3 right here for both sides. So again, step 1 is going to be what? 2 over 2 plus 3, which is just 2/5. That makes sense to everybody. You can do that in your head. Okay? Need to label the coordinates here. Now notice everything's grown by 1 now, so let's keep that in mind. So this is really -2, -1. And up here is really what? 8, 5. And if I do my triangle, right? So in my x direction, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. And in my y direction, 1, 2, 3, 4, 5, 6. Perfect. Okay? So let's do this. I'm going to have my, so this is my step 2 for x. I'm going to have, what? 2/5 times the x distance of 10. Perfect. Which 1 goes in there twice. It's going to equal 4. For my y, I'm going to have 2/5 times 6, which is 12/5. Or, as I like to say, if we're dealing with fifths, it's just 2.4. That's not too bad. Okay? Now let's go into step 3. Step 3 says, all right, let's add. So I'm going to have -2 for the x plus 4 equals 2. Step 3 for the y is going to be my -1 plus 2.4, which equals 1.4. Boom. Look at that. So what is my resulting coordinate? It is going to be 2, 1.4. And let's look at that. If we go to 2, we go up to 1 about 0.4. Boom. Right there. That's going to be our new, what is that? Find R. Boom. That's it. With that said, kick that fractional distance on a coordinate plane and peace out.